So did you start the HSS to HSS movement frame system in undergrad, or that's your
No,
more like PhD?
yeah, that's funny. I don't know how to turn this off. It's fine. So I started in undergrad. I was doing research on cement composites with fiber. And so when I applied to Michigan, I applied and I got asked to come work for a research group doing very similar things. So there's a research group there that's doing, they call it engineered cementitious composites. And so I went and worked in that research group for a year. And I was on fellowship, which means I was it's a kind of a really nice way to get paid, right? Because you can kind of do whatever you want to do. And so I found I was somewhat interested in it, but it wasn't exactly for me. But the interesting thing is the summer between undergrad and graduate school, I was an intern at AISC, so the American Institute of Steel Construction, you know, the big book, right? I interned I interned there for their engineering department. And so that was really just a great internship. I learned so much. I made so many connections of people and whatnot. And so what I ended up doing then is I decided, no, I kind of want to do something related to steel, like after a year. Actually, after 9 months, it was after the school year, essentially. And so I changed advisors to a very brand new faculty. I was his first student doing PhD. And so Jason McCormick is the advisor I had. And you see his name on those papers, right? And then he and I ended up talking to some of the research people at AISC, like talking and seeing what their needs were. And then he got some funding. And then mostly it was him after that, right? And I was just doing the research, but getting funding. And I went and started doing work on steel tubes. It's an area that's it's a bit confusing. The design of it isn't as straightforward. I guess let me take that back. It's not straightforward. It's not taught in school very much. And so I feel like if everyone learned about steel tubes and then we came and said, okay, now you have to design wide flanges, they'd be like, that's confusing, right? But it's just like, you're just not exposed to it as much. And so it's a bit more confusing for people to do and design. And there's some unknowns. There's less research out there on it. And so our question was, you know, are we missing something with steel tubes in terms of behavior or performance that we could gain compared to wide flange sections, right? So like actually in Asia, especially Japan, and I think in China as well, like super common to use steel tubes for columns. Like they're just really common. Our question was like, okay, we know that there in the US, it's not very common at all to use a steel tube as a column, although it's common to use them as like posts, like in buildings, like in warehouse buildings and all sorts of things, but not like as a column in a 20-story building or something like that.
Yeah, or just like the bracing near like, you know, staircase for framing.
Yeah, definitely used for brace frame systems, but built into built into a wide flange column system, right? So we thought, well, is there something there we're missing? Could there be some behavior performance increase that would be beneficial? And because there are some nice things about it, right? They're braced, the flanges and the webs are all braced, right? Instead of you have unbraced flanges on a wide flange, so you get a little bit lower B/T ratios on it, which means you're more susceptible to some buckling issues. There's some nuances to that because steel tube is only made in certain sizes, so it has some nuance, but and it's a bit thinner than you know, getting a 1-inch thick steel tube is possible, but it's not common. And then the other thing is that, you know, it doesn't have any lateral torsional buckling, really, any issues with that. It's so torsionally rigid that for most lengths, you don't really have any issue related to lateral torsional buckling. And so we thought, oh, let's see if, you know, what the benefits are, how you would connect these. Could we make a moment connection with steel tubes? Do steel tubes have the cyclic performance that they need to be in a seismic system? And we kind of went through that questioning, and so we did that through both experimental studies. So there was kind of 2 rounds of experimental studies. The first one was just the tubes themselves and looking at the cyclic performance of the tube, getting it to understanding the plastic hinge behavior of the tube itself. And then the second study was an actual moment connections. And so I think I had in my thesis, I probably had 2 by the time I left. I left to go teach right before the last test, and I think there was 2 or 3 in my thesis, and there was a 4th, and I think there were 4 total, 3 or 4 total. I can't even remember. It's been it all blends together, right? It's been I graduated 2013, so it's been 7 years since I did that, and so the papers have been coming out. They came out. I think everything has been out for the last couple of years now, at least. But yeah, and so we learned a lot about that behavior. And so Professor McCormick has now taken that to kind of the next steps, right? So he's looking into different types of connections, more in depth about the behavior of the connections, fracture behavior of the connections, and just trying to understand that and be he's helping the steel tube industry, but he's helping people understand the behavior of steel tubes and the usefulness of those in the US, essentially. There's another faculty member in Canada and at the University of Toronto who's also very, very into that, and that Jeff Packer, also a very good researcher as well. And so they're working together on that. And slowly these things are not what I did, right? But like steel tube work is getting applied to the code a little bit and updating the code. So one of the interesting things, because of the work that's been done by those researchers, especially Dr. Packer, there used to be chapter K, and there still is a chapter K in the steel specification, but slowly they've gotten the tubes, and chapter K focused on steel tubes only. Let's just to make it clear. Slowly we've gotten steel tubes into chapter J, which is the just regular connections or joints chapter. And so, it is slowly they're advocating and getting people to understand tubes are just the same but a little different, which is a good thing. So yeah, that was my PhD essentially. And during my PhD, I did do a lot of finite element modeling as well. And so a lot of working in Abacus. And so I still do that to this day, use Abacus as a software to help me in a lot of different situations. And so it's been really, really a useful tool, actually, really useful. And I still do to this day a lot of experimental studies. I've done big ones. And so all of that background I learned, right, has been like really, really excellent in terms of I was able to, jump into in an experimental study with no big issue at all. It's, even though it's a totally different topic, there was some wind tunnel testing here. Right, like I had that background, and then the modeling stuff. Like I've had some stuff come up recently for some windows, and we're wondering about the stresses that are in the windows. And I was able to use my modeling background to model the glazing, so the glass itself, and put it under some different temperature changes and see what stresses were induced in the glass layers, and so. That's why I say the basics are the basics, right? Once you kind of understand that, that's the really important part. So. Yeah.
Actually, I want to have a few questions regarding the paper. I know you guys compared the HSS, like to HSS versus the HSS to wide flange, but then is there like any cost comparison? Like. Yeah,
that's not my forte. Yeah, so. Definitely steel tube can be more expensive. It's just not as widely available. It's not rolled in the same way. So the manufacturing process for steel tube is just, but so there's that. But then there's the other side of it where like there's things that you don't need to do for steel tube that you would need to do for a wide flange that could end up labor costs. So we never did a really like hard cost analysis, like a cost benefit analysis of like what a tube frame system would cost versus a wide flange, you know, to tube, or, you know, we just never got that in depth in cost. It wasn't the issue, right? And I think, you know, as researchers, it's not always, you know, we have some thought about cost in the back of our head sometimes, but it's not always the driving factor, right? Like, obviously, we're not going to make steel tube out of gold, right? We're like gold tubes, right? Because it just doesn't make sense, right? It's number one, the cost. Number two, like the material properties don't work right. We have to think sometimes in kind of you know, the scaling of how these things would happen if, let's say, like the tubes are adopted widely and used all the time, right? Or there's some sort of design issue that is taken away from this use of steel tube, right? That could, you know, hence like one of the big ones was the lateral torsional buckling issue, right? You don't need to brace the compression flange or the tension flange of any of these tube members by code. Like there's technically you probably should, but the code doesn't really require any of that. And so that could really reduce like the ability or the cost associated with those sort of issues, right? And so there's one cost benefit, but then there's the downside of all the connections are a little bit complicated. Okay, so it takes a little more time to fabricate. Well, maybe some of the materials are lighter. Okay, so it's less steel material, so that's cheaper. But well, you know, so we didn't go down that road, but it's definitely something that like an owner, when they're building a structure, would need to consider if they wanted to employ the use of tubes, right? Yeah. So I hope does that answer the question?
Yep.
Okay, good question.
Yeah. Last one.
Last one, no, that's okay.
Last one regarding this paper as for now.
Good.
So I saw like welding was used to like connect, but then did you guys consider using like bolting? Because, you know, what we learned in school is like bolt is much better when it's like, you know, when encounter like seismic load or stuff. But like, is there like a particular reason you guys using welding, or did you guys consider using bolting?
Yeah, so I'll answer that. Yeah, so there are benefits. Okay, so you kind of mentioned bolting and seismic. So bolting, and there are some benefits to using bolts, but there are also some benefits to using welds for seismic loads. And so, you know, but we considered welding only in this case because of the fact that this was kind of a newer research project. Bolting is quite complicated with steel tube, and it's an issue, one of the major drawbacks of steel tube. And that the reason for that is there's no way to really access the backside of the bolt, right? If you put a bolt hole through a tube, right, you can't, how do you tighten it, right? Like it,
I see.
Right. And a through bolt is not a very good bolt condition. Like the way that bolts need to be applied is that the bolt should be tightened against, they call the faying surfaces. So there's the surfaces that, you know, 1, 2, or 3 surfaces should be tightly pulled together. So putting it through the tube like a through bolt just doesn't work well. It doesn't get enough tension in it, the bolt, and it's just not gripping quite tightly enough. And so, you know, the way to kind of start a problem, right, is let's look at the basics first, right? We know we can do all welded moment connections. That's not a big deal. And we know that some of those connections that I worked on could be converted to some of the bolted connections, right? Especially the ones with the collars or the diaphragms that are, you know, external or internal. You know, they're all external, internal, right? What we could do is, on that outer diaphragm piece, right, is add some plates that are shop welded in with bolt holes, right? And then that bolt, and then have holes in the diaphragms that are attached to the columns as well, and then bolt them on in the field, right? So essentially you'd be just a little bit of different operation. And so that's doable. But, you know, that's just another level of complication that we weren't interested in understanding at a time, and saving that kind of for the next steps, right? We really wanted to answer the fundamental question of, you know, how do these connections behave under seismic loading conditions? And so avoiding the bolting question is just, right, like when it's the scientific method, right? You just have to step back to that, right? Like we have a hypothesis and we think about how something's going to happen, right? And we're about it, we research it, and then we have all these factors we want to, you know, variables that we need to consider. We have to have controls, right? And I'll tell you, in civil engineering and engineering as a whole, and I'm sure in science too, doing the scientific method is an imperfect practice always, right? Because you can never control everything. And so, and especially engineering, I would think, that's my thought there. Maybe I'm wrong, but I'm not a scientist in that way. I'm an engineering, right? But like, you have no idea of the exact material properties. You have no idea of the weld properties. You don't know, you don't have everything perfectly characterized with the welds, nor will the welds be laid down perfectly, right? Right. So there's all these like unknowns, right? Like, you have to just limit yourself at a certain point, like of what we can answer and understand well at this time. And so that's what we decided. That was it. So I don't know if I don't think Jason's got into, so Jason, Dr. McCormick, has gotten into any more bolted connections with these. I don't think he has, actually. I think it's kind of, I think they did some stuff with collars where you have collars wrapping around the column and you slide in and then weld quickly. And that seems pretty effective. So they're just thinking about some different ways to use welded connections. Bolting is tough with tube. I'm not gonna lie, it's a challenge. So yeah, good question though. Any more?
Very interesting paper.
Yeah.
I really learned a lot from it. Like,
good.
I personally like had some experience with HSS like during my internship, but like I mentioned, it's for like the bracing. It's used as a bracing with like the wide flange. Okay. And then in my undergrad senior project, actually, like my team actually used HSS as the truss frame.
Great.
So it's like, but then it's only one floor, and it's the project we set it in New York City, so you know, not that much seismic consideration. So it's good that I read your paper and learned a lot from it.
Good.
Kind of overwhelming, but then it's good.
Good. I'm glad that you were able to learn from it. That's good. Yeah, there's several papers out there by Dr. McCormick that would be useful for you to look at, as well as Dr. Packer if you get more interested in HSS and understanding behavior. So that's really important. So that's just something to consider.
Yep.
Yeah.